Okay, we're going to have a go at this. We have a new theorem to talk about here, and then we are going to use lots of the things we've learned to start to figure out some things about zeros. So we'll use the calculator starting with number 5 here. So the rational zeros theorem, a lot of the books will talk about P over Q. So P represents the factors of the constant. So in each of our polynomials, we will look at the constant term, which is your last term here. The Q represents factors of the lead coefficient. So we will look at the lead coefficient now for things other than end behavior. Whoa. Whoa. Okay, I don't know what that was all about. Alright, so we've got the lead coefficient here. Okay, so what I typically do with this theorem is I think of factors of 21, such as 1, 3, 7, and 21. Each of those integers divided by 1, or plus and minus 1, which is the lead coefficient of this entire polynomial. All of those factors divided by 1 simply equal themselves. Now, what that means is if this polynomial graph crosses the x-axis at any rational locations, that is nice, pretty fractions, decimals, or integer places, they must be part of this list. So some of the things you can say about this polynomial graph would be it can not cross at 2, or -2, or 4, or 5, or 57. It could cross at none of these places, but if it does cross or have an x-intercept at an integer, rational, fraction, or decimal place, it must come from this list. Now that sounds kind of weird. So for right now, we just sort of practice this. So for this problem, we need factors of 10 over factors of 5. So let's go through the factors of 10. 1, plus and minus 1, 2, 5, and 10. All of those divided by 1. And then also all of those divided by 5. So I can write them like this. And then we pick up 1/5 plus and minus 2/5. 5/5, if I listed it over here, is the same thing as 1, which I already have listed. And then 10/5, if I would list it here, is 2. So we pick up a couple of nice rational fractions. So this polynomial could cross at 2, it could cross at 1/5, it could cross at -2/5, but it can't cross at 3, or 4, or 6, or 12. Or it might not cross at any of these places. So that theorem might not sound very useful to you, but when I was a student and didn't have a graphing calculator, it was very useful. Okay, so now we're going to look for the real zeros of this function, and we're not being really given any clues. So first thing we might do is take a little list. What are some of the factors of 8 over factors of 1? Plus and minus 1, 2, 4, and 8. So it's possible the graph might cross at one of these places. So we actually go to graph this sucker, and if you just look at the graph, you can sort of guess where you think it's crossing. I think with a scale of 0.5, it looks like it's crossing at 1. Maybe it's crossing at 4. And I think it's crossing at -2. Now, -2, 1, and 4 are actually all numbers part of this list. So what we might want to do now is maybe just check the table to see if we are correct. So there it is. It crosses at 1, crosses at 4, and look at that. It also crosses at -2. So what I will ask you to do, which may not be the point of this problem, you would list 1, -2, and 4. Those would be the zeros. But I'd like you to do a little bit more. Let's do the synthetic division and prove that these are zeros. Now, this is going to be a step that you have not done before. It's kind of fun. First synthetic division with a location that we are sure is a 0. So 1 times 1 is 1. Add, multiply, add, multiply, add. Check. Now, we're going to say, hey, you know what? I also think it crosses at -2. What I do now is I do the synthetic division with what's left, and I've got fewer numbers, and it goes a little faster. Well, check that out. But I also think it crosses at 4. Watch this. We'll go all the way down. Check. We just verified that all 3 of those locations are truly zeros. Let's try this with number 10. So I'm going to have to change that polynomial. Whoops. Whoops. It's hard to do this the way you guys do this. Alright, so let's change the polynomial. X cubed plus 4x squared plus x minus 6. Okay, new polynomial, crossing at a couple of different places. Let's start with the possible rational zeros. So it would be factors of 6 over factors of 1. So that would be plus and minus 1, 2, 3, and 6. So let's take a quick look at the graph. Looks like it might cross at 1, and then maybe -2, and maybe -3. Again, all numbers that do come from this list. So let's start with 1. We think it crosses at 1. Let's do the synthetic division. 1, 5, 5, 6, 6, 0. Now we think it crosses at what? -2? 1, -2, 3, -6, 0. And we also think it crosses at -3. Last one. Check. So my zeros are 1, -2, and -3. Good job. That was huge.